In the first half of this lesson, we learned about SOHCAHTOA. So to review, an angle theta has three sides in relation to it. You have the opposite side, you have the adjacent side. Adjacent means the side touching it, but not the hypotenuse. The hypotenuse is always the one across from the right angle. And we learned SOHCAHTOA. So what that meant is sine of an angle equals the ratio of the opposite side divided by the hypotenuse. The cosine of an angle is the fraction made by the adjacent side divided by the hypotenuse. And the tangent is equal to the opposite divided by the adjacent side. All right, so now we're going to learn about the reciprocals of all three of these. The reciprocal of sine is called cosecant, and so that's hypotenuse divided by opposite. The reciprocal of cosine is secant, so now hypotenuse is on top and adjacent is on the bottom. And the reciprocal of tangent is cotangent, so that's adjacent over opposite. So the easiest way is just remember SOHCAHTOA and then flip them. It's pretty easy to remember that tangent and cotangent go together. The other two, not so easy. Just remember that the S's do not go together. So you have SC, and the other one is the C goes with S. Alright, so for a lot of these triangles, you're going to need to do the Pythagorean theorem. So let's review some Pythagorean triples. So Pythagorean triples are sets of numbers that satisfy the Pythagorean theorem. So some common ones are 3, 4, 5, 5, 12, 13 also satisfies the Pythagorean theorem. Another common one is 8, 15, 17. And there's also 7, 24, 25. Okay, so for these problems, we're going to find all 6 trigonometric functions for angle theta. Okay, so for number 1, we see angle theta is in the bottom left. We see on the opposite side, there's an 8. The adjacent side is 15. So the Pythagorean triple says the hypotenuse has to be 17. So sine theta is opposite over hypotenuse. Cosecant will be the reciprocal of that. Cosine theta is adjacent over hypotenuse. So secant will be the reciprocal. Tangent is opposite over adjacent. So cotangent is the reciprocal of 8 over 15, so 15 over 8. Alright, number 2 and 3 are the same thing, but we have to write out the trig functions ourselves. So we're going to do sine theta, cosine theta, tangent theta, and their reciprocals. Sine's reciprocal is cosecant. Cosine's reciprocal is secant. And remember to write theta each time. Alright, so this is a Pythagorean triple. This is a 3, 4, 5 triangle, but with every number multiplied by 3. So this is a 3, 4, 5 with all the numbers multiplied by 3. So 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. Okay, so what you can do actually is instead of reducing 6 times for all 6 trig functions, you could reduce it now. And if you reduce it now, it's a lot easier to reduce it once than to have to reduce 6 times. Alright, so let's label. This is the opposite side from theta. This is the adjacent side. And here's our hypotenuse. Alright, so katoa sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And now let's just flip all 3 of those over, and we'll have the other 3. Alright, for number 3, that is not a Pythagorean triple, so we're going to have to do the Pythagorean theorem. So we know that 9 squared plus 4 squared equals c squared. So that's 81 plus 16 equals c squared. So c squared equals 97. So c equals radical 97. Alright, from theta's perspective, this is opposite, this is adjacent, and this one's the hypotenuse. Okay, so sine theta is opposite over hypotenuse. You are not allowed to leave a radical on the bottom, so you need to multiply the top and the bottom by that radical. So the top gets multiplied by radical 97, the bottom gets multiplied by radical 97, and the radicals cancel out. Alright, so for cosine, same thing. This is 4 over radical 97, but we're not allowed to leave a radical on the bottom, so we multiply the top by rad 97, and the same thing with the bottom. For tangent, tangent's opposite over adjacent, so that one doesn't need us to rationalize the denominator. Alright, the reciprocals. Reciprocal of sine is cosecant. And when you take the reciprocal, do it for the first step before you rationalized, because then you don't have to rationalize the denominator. So again, flip the fraction from the first step, and then you don't have to do any extra work. Cotangent's easy because it doesn't have a radical. Alright, on the back they don't give you the triangle, so you're going to have to draw it yourself. They do give you one of the 6 trig functions. Okay, so draw a right triangle. A and B are acute, so put A on one of the acute angles. I'm just going to put it here. You could have put it on the other one if you wanted to. Alright, so they tell us tangent of A equals 12 over 5. We know that tangent is opposite over adjacent, so I'm going to put a 12 on the opposite side of the A. I'm going to put a 5 on the side adjacent to A. That looks like a Pythagorean triple, 5, 12, 13. And now we write out the other 5. Okay, so we want sine, and not of theta, but of A this time. Sine of A is opposite over hypotenuse, so let's label these sides. This is opposite, this is adjacent, this is hypotenuse. Alright, so opposite over hypotenuse. Cosine is adjacent over hypotenuse. They gave us tangent, but let's write it again because it'll help us find cotangent. Right, cotangent is the reciprocal of 5, or the reciprocal of 12 over 5 is 5 over 12. Secant goes with cosine. And so I'm going in a different order. Cosecant of A will be 13 over 12. So again, they gave us tangent, and we found the other 5. Alright, so for number 5, draw a right triangle. I'll put B up here. We know that sine is opposite over hypotenuse. So on the opposite side of the B, we have to put a 4. On the hypotenuse, we put a 9. Now we're going to do the Pythagorean theorem. 4 squared plus, and I'll call this A squared, equals 9 squared. Alright, so moving over here, 16 plus A squared equals 81. Subtract 16, A squared equals 65. So A is going to equal radical 65. Let's label these sides. This is opposite. The 9 was the hypotenuse, and this one is the adjacent side. Alright, sine B was given. So the reciprocal of that one is cosecant B, which is 9 over 4. Cosine B is adjacent over the hypotenuse. So then secant of B, I have to flip that. And I have to rationalize. So I'm not allowed to have radical 65 on the bottom. So I multiply the top by radical 65. And I multiply the bottom by radical 65. Tangent of B is opposite over adjacent. Not allowed to leave a fraction on the bottom, so we multiply the top by radical 65, and the same thing on the bottom. Alright, flipping that. Flip the first fraction, and you get rad 65 over 4. Alright, so those are the 5 answers. We don't need sine, because that one was given. Alright, so now we're going to use a calculator to evaluate these. So notice it is the angle that we're solving for. So when you're solving for the angle, you need to use second and then the button. So this is called inverse trig. When you're solving for the angle, use inverse trig. So the way you make cosine cancel out, a lot of people say divide by cosine. That doesn't really make sense. So what you want to do is you want to use inverse cosine, which shares the same button on the calculator. So you're going to take the inverse cosine of both sides. So these cancel each other out. And now, the way we do this on the calculator, don't just push cosine, you have to push second and then cosine, and it looks like cosine to the negative 1 power. And if you do this, cosine to the negative 1 power and then put 3 over 14 in parentheses, you get 77.6. And this is an angle, so we put degrees. So again, that's called inverse cosine. Sometimes it's called arc cosine. Alright, so how do we make tangent go away? We take the inverse tangent of both sides. So if I take the inverse tan on the left, tangent cancels out. This is also sometimes called arc tan. So inverse tan, arc tan, same thing. Alright, put this in your calculator, push second, then the tangent button, and then 5 in the parentheses. So the angle with a tangent equal to 5, that angle is 78.7 degrees. Okay, for the last one, we have a complicated word problem. So recall that an angle of elevation is made by two lines, the line looking up and the horizontal line. Alright, so we have an angle of elevation to the top of a pyramid. So angle of elevation also uses a horizontal line, and that measures 35 degrees. This person then walks further away, so he goes 150 feet this way, and then he finds the same angle of elevation, but now that angle is smaller because he's farther away. That angle is 22 degrees. Alright, so we're trying to find the height of the pyramid, which is here. So because this is a vertical distance, I'm going to call this y. Now we cannot do SOHCAHTOA with the blue triangle yet because we don't have any sides. So let's actually try that. So whenever the hypotenuse is not labeled, I know it's tangent because tangent uses opposite and adjacent. We know that tan 35 equals, so opposite over adjacent, and we run into a problem because there's two equations, or there's two variables that we don't know. Alright, so now let's try it for the red, or for the big triangle. So we have tan 22 equals, what's opposite to that side? That is also y. What's adjacent? Well, adjacent is this whole thing here. So adjacent is x plus 150. Remember that SOHCAHTOA you could only use for right triangles. So you can't use SOHCAHTOA for this triangle because it's not a right triangle. You have to do it for this whole triangle, and then you could also do it for this smaller right triangle. Alright, so both of these equations have two variables. We learned a long time ago that in order to solve two equations with two variables, that's called solving a system. So the equation on the left, I can solve that for y. So if I multiply x to the other side, I get that y equals x times tangent 35. And then for the other equation, if I multiply x plus 150 to the other side, we get that y equals x plus 150 times tan 22. Alright, both of these are equal to y, which means they are equal to each other. So we could set those equal to each other. x tangent 35 equals, and I'm going to distribute as I do this, x tan 22 plus 150 tan 22. Alright. Now anything that has an x, you want to put those on the same side. Alright, we did problems similar to this when we learned about logarithms. Then you factor out an x. Now you take the parentheses on the left and divide that on both sides. So the right side is going to get divided by the parentheses on the left. All right, and remember to put parentheses down here so that the numerator gets divided by both of those. So if you put that in your calculator, you get that x equals 204.6. The problem is we weren't asked to find x. We wanted to find the height of the pyramid. So I think the easiest way to do that is take what we just got and plug it in right there. So take the number that's already on your calculator and multiply by tangent of 35. Okay, so doing that, I get 143.3. So y equals 143.3, and the units were feet. So the height of the pyramid is 143.3 feet. Alright, that's it for this lesson.